Okay, in this section we're going to talk about polynomial, and so these are the objective. Determine the behavior of the graph of a polynomial function using the leading term test. Factor polynomial function and find the zeros and their multiplicity, and try to solve some application problem. So this is the definition of polynomial function. As you can see here, this one. This is how we write any polynomial function. Keep in mind, don't worry about these notations like an minus 1, an minus 2, and then dot 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 means keep going like that. A1, A0. These are just some real number. Okay, I'm going to give you some examples here. These are just the notation for some numbers. Like here, these are the examples here. If you have a function like this 4, so that means if you want to write down in this form, that means a0, which is a constant, is 4, and a1 is 0, a2 is 0, and then a3 is 0. This dot 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 means keep increasing that. Everything is 0 because there is no x terms. So here a0 is 4 and rest of the a's are 0. Here a0 is 1 and next is a1 is 3. Here a0 is 9, the next one is negative 1 and next one is positive 4. So a0, a1, a2, keep going like that. Okay, these are the names of the polynomial function. This is called constant, linear, quadratic, cubic, quartic. So these are the function we were using before, but we can call them polynomial for any of this type of functions. And these are the degrees coming from the highest power of x you can see in the polynomial. So like here 4 is the highest one, that is why it's a degree. 4, 3 is the highest one, that's why degree 3, and then so on so on. So this is very popular graph example function. We already discussed about quadratic function in detail. So this is also a polynomial function. This is the graph. As you can see here, the degree of the polynomial function is 2. You can factor this like this, and based on the factor you can find zeros, x-intercept. X-intercept means these zeros and with the y value 0. Y-intercept means when x is 0. Minimum value can be found using the vertex, and maximum is nothing, no maximum here. The domain is all real number, and then range is starting from here and going up. That's why it's a -4 to infinity. So the graph of any polynomial function can be divided into two different categories. One is like this, quadratic. Another one is cubic. So this is the cubic function, and from the function you can find out all this information. So factors, they give you the zeros, because when x is -4, this part is 0. When x is -1, this part is 0. And from the zeros you can find the x-intercept. If you put x equal to 0 in the function, that gives you the y-intercept. You can find the minimum value or maximum value. Don't worry about it. If it's not given in the graph, then there is no way you can find out the minimum and maximum at this level. We need more tools, but it's given here. That's why we found it. The main thing is you're supposed to know the domain and then range. From the graph, it's very clear. Okay, these are some examples of the graphs of polynomial function. For example, the first one is quadratic, second one is constant, third one is cubic, the fourth one is power 4, quartic. But these are the graph of non-polynomial function. These are the function but non-polynomial, like absolute value function. This is not a polynomial function. Square root function. This is not a polynomial. A rational function. X to the power 4 to the power 4 over 5. That they are not polynomial function. One thing keep in mind, if you look at them here, sharp turn here, it's undefined for some of the restriction here. Here sharp turn as well, there is a gapping here. So to plot the graph of a polynomial function is continuous and smooth. It's supposed to be continuous and smooth. The domain of the polynomial function is supposed to be all real number, but if you go here, they are not smooth. Like you have to draw like this, and all of a sudden you have to go to other way around. So this is sharp, no smooth. So whenever we try to plot the graph, keep in mind the graph supposed to be smooth, continuous, and then the domain supposed to be all real number. So when we try to plot the graph, we also have to be mindful. If the polynomial has a degree even, then graph supposed to be either like this or like this, meaning whenever we try to plot the graph, let's say here is the coordinate system, to the extreme right or to the extreme left, there is certain type of behavior the graph is going to follow. That's called in behavior. In the middle, in the finite zone, we don't care. Like this means we don't know. This part we don't know. But towards the end, to the extreme right or to the extreme left, when x is very, very, very high or very, very, very low, the graph supposed to follow this pattern. If the degree is even, if the coefficient is positive, the graph has to be up both sides, up here, up here. If the leading coefficient is negative, it's supposed to be go down here and go down here. In case of even degree, if it's odd degree, it's supposed to be up on the right side and down on the left side, and then opposite for the opposite coefficient. In the middle portion, finite zone, we don't know actually exactly the graph could be different, for different function. Okay, how do you find the zeros of polynomial function? First of all, you need to factor, if it's possible, factor the polynomial function. And now each factor, equate it to 0 and solve for x. That's how you find the zeros. Even and odd multiplicity. Let's say you have a function, polynomial function, and these are the factors of that function. Then multiplicity means this exponent, how many times those factors are repeating. X minus 1 is repeating 2 times, and from here the zeros of this factor is 1. So 1 has a multiplicity 2. 1 is the 0 of this factor, has a multiplicity 2. Here negative 2 is the 0, and the multiplicity means exponent of that factor, it's repeating just 1 time. So the multiplicity, the 0, negative 2 has a multiplicity 1. So there is a very interesting feature we can use here, that is, if the multiplicity is odd, then the graph crosses the x-axis at that x-intercept. But if the multiplicity is even, then graph is a tangent to the x-axis. For example, let's say the function x squared. Here, what is the 0? 0 itself is a 0. And what is the multiplicity? Multiplicity is 2. So at 0, as you can see here, the graph is tangent to the x-axis. That is the meaning of this tangent. So if the degree of the polynomial is n, then you must have at least 1 0. That's the minimum, and at most n zeros. So if you are dealing with the 5th degree polynomial, then maximum zeros, number of zeros you can find is 5, and the minimum is at least 1. If you repeat the multiplicity, every polynomial function of degree n has exactly n 0 if you repeat the multiplicity. For example, let's say this is the polynomial. So what is the 0 of this polynomial? 1. But because it's repeating twice, you can say that there are 2 zeros if you count the multiplicity. Okay. So let's look at some examples here. Determine the leading term. Leading term means the highest degree. If you go from left to right, the highest degree is this one. So just copy everything here, which is negative 1 over 6 x to the power 4. That's the leading term of this polynomial. What is the leading coefficient? Leading coefficient means the number with the sign for this x to the power 4. That's called leading coefficient. In this case, it's a negative 1 over 6. And then degree means the exponent of this leading term, x to the power. That power is the degree of the polynomial, which is 4. Okay? And the polynomial is, the name of the polynomial, because it's a degree 4, it's called quartic. Very similar question. I'm going to skip it. Okay. Use an in behavior diagram. So meaning we're talking about this. So you have to find out what is the degree, the leading term. The leading term is this, and what is the value of n. So in this problem, as you can see here, the degree is 6, so even, and the coefficient is negative, so that means here. So it has to be down. So the only graph you have down is this one. Use the leading term test to match the function. So keep in mind, leading term means it's an even degree, negative, so the graph supposed to be like this, down. So find out the graph which has down both sides. So this is the only graph I can see down both sides. Rest, they are not down. Watch the video and then solve the problem given below. Find the zeros. So either you can watch this video or just watch my work. Zero means what makes this individual factors zero. X equal negative 1 and x equal negative 1, x equal to negative 1. It's repeating 3 times, but negative 1 is one of the 0. And then the last factor, when you put x equal 5, that makes that thing 0. So negative 1 and 5 are the two zeros. Now multiplicity means how many times this x plus 1 is repeating. Because x plus 1 is a factor for negative 1 as a 0. It's repeating 3 times, so the multiplicity is 3 for the first one, which is smaller 0 because it is negative. And then for the second one, the multiplicity is 1 because it's not repeating, it's just one time. What happens? Did I do something wrong? Oh, they are just asking you smaller 0 has a multiplicity, not both of them. I just tried to be smart here. Okay, my bad. So now the larger 0 has 1. That's where I have to put the answer. Okay. So find the zeros of this function. You need to find the factors if it's possible for this type of problem. Let me just show you how can you do that. If the problem is easy like this, then you can find the factors. If it's quadratic, then no problem. But if it's more than quadratic, then you need to work a little bit hard. So here in this case, finding the factors, finding the zero needs finding the factors. So this is the polynomial x cubed 9 times x squared negative x minus 9. I can make group. I'm lucky here, it's going to be, I can find the factor using the grouping method here. So the first two, the common factors, x squared, the leftover is x plus 9. Last two, the common factor, there is nothing, that means negative 1. So when you put negative 1 outside, you have to copy x and then you have to change the sign here. So that negative becomes positive. So now from 4 different terms, you have 2 terms. Here is the 1, x plus 9, which is common. So I'm going to factor out that x plus 9 and write down this x squared minus 1. And for the x square minus 9 minus 1, the factors are x minus 1 and x plus 1. So these are the three factors for this polynomial. And then from here we can find the zeros: -9, +1, and -1. So -9, yes, -1, and then +1. These are the three zeros, and then they are not repeating. These factors are not repeating. That means the multiplicity is 1. Okay, the smallest zero is, oh sorry, one more time I made the same mistake. Smallest zero is -9 and multiplicity is 1. And the middle zero is -1, and one more time the multiplicity is 1. And then large zero is +1, and then multiplicity is 1. Always read the instruction, okay? Even though you know the answer, if you don't follow the instruction, it would be difficult. I'm going to do one application problem here. If there are X teams in a sports league and all the teams play each other twice, a total of nx games are played, where nx is, so this is the polynomial which represents total number of games they play. So this function can be used for a situation like this. A softball league has 6 teams, so total number of games supposed to be the value of n at 6 is 6 square minus 6, which is 30. 36 minus 6 is 30. So the total number of games they have to play is 30. Each of which play the other twice. If the league pays $40 per game, so then for 30 games it has to be 30 times 40. So if you just multiply this, it will be 1200. So there will be total 30 games, and for each game there is a $40 payment, so the total payment is $1200. So that's all for this section.